Going on now to topic 6 of chapter 5, where we're going to do some special products that we did in an earlier lesson. When we see perfect square trinomials and the differences of squares. And these are the objectives. So let's get started. And the first thing they want us to do is to determine whether these are perfect square trinomials. Now, why do they want us to determine that? Well, because if they are, they factor very easily. Is the first term a perfect square? Yes. Is this a perfect square? Yes. What's the square root of 9? 3. Double it. Yes. So this works very well here. Had a little call there. Getting back to business here. Okay, so this is a perfect square trinomial, and we'll factor into this. And you can always try that and then see if it goes this way. Now, this is not a perfect square, so this one is no. This one is, but this is no. Now this, again, put it in standard form. And then take the square root of that, which is 4x. The square root of that, which is 7. Middle sign is negative. And yes, this is 1 here. Now, as you look at this, you might try it here. Just try it here. See if it works. This is going to be x minus half of that, or the square root of that is 6. Double it. Gives you a 12. So, yes, this is 1, too. Now, again, this is not in standard form, so put it in standard form. Now, this is a perfect square. This is a perfect square. So let's try it. Square root of that is 3z. Square root of that is 5. And that's going to be a negative. And 3 times 5 is 15. Double it is 30. So yes, this is 1. And this one, you need to factor out the a first. So we factor out the a, and then we get 4a squared plus 24ab plus 36b squared. So let's try it. Now the a would still go out there. Square root of this is 2a plus in the middle, and this is going to be 6b. And then 2 times 6 is 12, double it, 24. So this is a yes. Okay. And now they're asking us to determine whether the following show the difference of squares. Is this a square? No. So this isn't. Not the difference of squares. Later we're going to see this is the difference of perfect cubes, but not squares. And this is a perfect square, and this is a perfect square. And remember, these factor into their conjugates. So 2x plus 9, 2x minus 9. Now, okay, you could theoretically put this 16 minus 25x to the 6th, more in that form, but the answer is yes. This is the difference of perfect squares, and it will factor into its conjugates. 4 plus 5, x to the 3rd. 4 minus 5, x to the third. And now they want you to factor these. Okay, so this will factor into its conjugates. X plus 8, x minus 8. This will factor into its conjugates. 6s plus t, 6s minus t. Now here you need to factor out a 5 first. So if I factor out a 5 out of there, a 5x actually. So this gives me 4x squared, which is a perfect square. And this is going to be a 81, which is also a perfect square. So this goes 5x, and then the difference of perfect squares factors into their conjugates. 2x plus 9, 2x minus 9. Now if you put the minus here and the plus there, that's perfectly fine. Okay, well hopefully you're catching on, and these are sort of fun if you understand them and can work with them. Okay, let's go on to factor number 3a now. Now as you look at that, you might say, what's going on there? Well, it looks like they want us to factor this by grouping. So we're going to factor something out of there and something out of there. So here we can factor out an x squared out of these two, and then get x minus 7. And then here we're going to factor, this is kind of tricky, a negative 9 to get x minus 7. Notice we had to reverse the signs by factoring out a negative. Reverses the signs. Now we get x squared plus 9 from these two, and then we get a x minus 7. Now notice this is a minus. I got the wrong sign there. I said it but wrote something else. This is the difference of perfect squares, so you have to factor this as well. This will factor into x plus 3, x minus 3, x minus 7. These are conjugates, they go into that, and we are able to factor that polynomial using grouping. And I guess we're going to do that here. Maybe not. Do you see right here? This, if we put parentheses around it, factors into a plus 4, the quantity squared. This is a perfect square trinomial minus b squared. So we can then, in a sense, factor this into a plus 4 plus b, a plus 4 and then the plus b, a plus 4 minus b. In a sense, it's sort of a modification of the difference of perfect squares. And what do we have here? Yeah, this is just written a little different way. Watch this here. X squared minus, now we're going to reverse these signs, and this becomes y squared minus 10y plus 25. some little tricky stuff. So it's similar to this, but done this way. So this is x squared minus y minus 5, the quantity squared. This is a perfect square trinomial that we can now factor into x plus y minus 5. And then this is going to be x minus. Now notice this minus is going to affect one of these. This one didn't change, but this one I believe becomes a negative y and a plus 5. And let's check that down below. And there it is right there. Okay, so we're going to go to solve any of these. Now, in order to do these, we would need a calculator. So we're going to skip all of this. This is not going to be included in our work. Okay, that's kind of a good deal. We saved a little bit of some difficult stuff here. Remember we used the calculator to do this? Find the zeros and this one too. Now if they come out even, sometimes you might be able to do it, but we're not going to have things like this. Okay.